Life is difficult for Navy pilots who land jets on aircraft carriers. The first part is about landing in the exact spot and at the exact correct time so that the tailhook will hook the arresting wire and bring it to a stop before the entire 300 feet of the runway are used up. Additionally, flight decks move around constantly. They go up and down with the waves. A pilot frequently modifies his trajectory by hundreds of tiny modifications in the seconds prior to the touchdown. However, landing an aircraft on the deck of one of these carriers demands utmost caution, and American troops have developed some straightforward but effective strategies for making a safe landing in the middle of the ocean. Welcome back to another episode of High Technology. Join the club as we unravel high-end technologies on the planet by subscribing to this channel and hitting the notification bell so you won't miss any exciting videos in the future. In this video, let's see how the US military saves pilots landing on massive aircraft carriers. First off, FOD or foreign object debris is constantly looked for on the carrier's deck. FOD, as implied by its name, encompasses both the deck's runway and any item that is not a part of the airplane. They may harm crew members and damage an aircraft as a result of their presence. In fact, it's estimated that FOD-related damage costs the greater aerospace industry a staggering $4 billion annually. This phenomenon also applies to the naval forces because even a small object like a stone, nut, or washer can cost tens of thousands of dollars worth of repairs and work to be needed in the engines. One method the Navy uses to deal with this minor problem but has the potential to be extremely destructive is the usage of FOD walk along and regular inspections by the sailors. The sailors line up uniformly across the deck size at the end of the deck and do the FOD walk until they reach a preset halting place. While moving down the carrier deck during this operation, the sailors look for any foreign debris or objects that they may come across, picking them up as they go. This brief exercise seeks to prevent catastrophic events from happening to the Navy's machinery and planes. The countermeasure washdown system, a damage control system, is another tactic employed by the naval personnel on board. This system is an essential defensive element designed to limit damage and stop hazards from spreading throughout the ship. It is a procedure through which the Navy fights against chemical, biological, and radioactive warfare by using seawater and aqueous film form or AFF. The system can also employ seawater and AFF together to put out fires by suffocating a flame's oxygen supply in the event of a fire outbreak. The washdown system is typically a massive sprinkler system that draws water directly from the ship's bottom to the exterior. On the ship, hazardous areas are washed using this water. The US Navy launches aircraft from the deck of an aircraft carrier using a steam-powered or electromagnetic catapult mechanism, although one could ask how the tiny runway on the ship deck works. The armature, a part of a catapult to which the launch bar of an aircraft is connected as it takes off, is used by the electromagnetic system. This catapult device gives the airplane some sort of takeoff aid while enabling the aircraft to take off from a relatively constrained area. This system needs to be properly maintained, and sailors typically perform several maintenance checks to make sure it is in good working order. One of them is a check to make sure the launchers that use steam power have their cylinders properly aligned to prevent their pistons from being scoured. For the new generation of launchers that use electromagnetic systems, armature maintenance is essential, just as it is for the steam catapult cylinders. To get rid of any contaminants such as dirt, dust, oil, and other impurities, the armature is cleaned with the contact cleaner. The armature's commutator is next examined for debris and cleaned using aluminum oxide paper before receiving a final cleaning with the cleaner, at which point it is ready for use. A holdback bar extends from the back of the plane's nose gear to the flight deck, where it is fastened into the flight deck, while the launch bar is permanently attached to the front of the plane's nose gear. When the correct pressure is reached, the aircraft that is being held back by the holdback bar is fired down the steam-powered catapult. The steam-powered catapult pistons are locked in place to allow the cylinders to build up pressure. When the pistons are released, which also releases the holdback, both the shuttle and the plane are driven forward by the pressure of the steam. The launch bar separates from the shuttle when the plane reaches the end of the catapult, allowing it to accelerate rapidly from 0 to 160 knots in just 2.5 seconds. Jet blast deflectors or JBD are also used by the catapult system to shield personnel and other aircraft from harm caused by exhaust blast. The JBDs are raised and lowered by hydraulic cylinders or linear actuators and are constructed of heavy-duty materials. When the aircraft is ready to take off, the JBD is raised to guide the hot jet blast and high-speed wind created by the engine exhaust, which can reach hurricane-force winds of up to 120 miles per hour. Despite the fact that land-based catapults can be utilized for testing and evaluation but not for routine operation, catapult systems are typically typically deployed on aircraft. The jets are launched by catapults during this land-based test, and they are recovered using aircraft carrier-style arresting gear. The land-based catapult is built on a cable tow propelled by a capstan which is driven by turbine engines, in contrast to a catapult found on an aircraft carrier which goes down a track on the deck. Without the requirement for a long conventional runway, the complete arrangement would allow the aircraft to take off and land back at the base. This test was carried out to identify the catapult system's performance constraints and to develop more effective evaluation methods for regular deployment on carriers. Similar to this, the Electromagnetic Aircraft Launch System or EMAS technology enables smooth acceleration of the aircraft at different speeds, enhancing the carrier's capacity to launch aircraft in support of the armed forces. It uses solid-state electrical power conversion and stored kinetic energy instead of the conventional steam-powered catapult, which puts less strain on the ship and its components. EMAS is a cutting-edge system that supports extensive computer control, supervision, and automation. The airplane is connected to a shuttle by emails, and the shuttle is then propelled along the catapult track by an electromagnetic field created by linear induction motors. When the launch is started, the motor generator releases the energy it has stored in the momentum of its rotor. Dead load testing, in which the launch system would fire car-sized metal slugs off the carrier deck to imitate airplanes. Testing is done to demonstrate the system's dependability and confirm that it operates in accordance with specifications. The electromagnetic system is also used by the naval forces to create the railgun. The railgun is a weapon that fires high-velocity projectiles using electromagnetic power. It is hoped that this railgun will fire several more rounds of ammunition than the standard naval gun shells while using less space for each shell and less hazardous explosive material to be transported on board the ship. In order to complete the circuit between these conductive rails, a projectile held in an armature is loaded into a railgun's two parallel metal rails. A powerful electromagnetic field is produced by the application of a large number of electrical pulses, and this force drives the bullet down the rails with hardly any recoil. The development of this tool demonstrates once again the naval forces' dedication to use technology to aid in the accomplishment of naval warfare objectives. At the Naval Surface Warfare Center's testing facility in Virginia, this warfighter game changer was put to the test. The system charges for a few minutes and fires in less than a second. It is shielded to prevent interference with onboard system and controls, and the projectile that is launched travels at amazing multiples of the speed of sound for more than 100 nautical miles. It covers a large region, reacts remarkably quickly, and provides the forces with some cutting-edge lethality. It is meant to support ballistic missile defense, cruise missile defense, and air defense. The naval forces have undoubtedly developed effective ways to carry out their duties efficiently with complete assurance of people's safety, ranging from straightforward safety procedures like the FOD exercise to a more complicated defense mechanism like the railgun. The Navy is showcasing how simple but effective the original design concepts actually are by using the present technology systems as the blueprint for the future designs. An aircraft carrier built by engineers has stood the test of time and will be in operation in some capacity for a very long time. And that's a wrap for today's video. If you enjoyed this content, please don't forget to like and hit the subscribe button and turn on the notification bell so you can always get to watch more incredible videos like this. This has been High Technology, serving you the best in cutting-edge contents on the highest form of technology available on the planet. See you on the next one.